Hey guys, we're going to go over the test corrections for 2A and 2B. Okay, so first, to answer a lot of the questions I get on this norm CDF calculator, and I'm just going to show you, I go to Google, type in the word norm CDF calculator, and notice the first or second one that pops up for me is this online stat book. So I'm going there. Now, you are allowed to use this on the test. You're not on the AP exam, but I've noticed just the more the students use this, the better they start understanding what it is, the numbers they're typing in a calculator. And then I can kind of teach them how to use the calculator to do exactly the same thing. So let's do it. Okay. So question number, we'll just start on version A alphabetically. And we're just using Christian's paper because most of these are right, and he wasn't there the day we handed it back. So it says the height of American men, 18 to 24, are approximately normal, which means we can use a norm CDF calculator with a mean of 68 and a standard deviation of 2.5. So I'm going to put a mean of 68 and a standard deviation of 2.5, right? Then it says, half of all the young men are shorter than what? So looks like we picked 68 here. So if we think about this, if I type in 68 here and I hit calculate, see, doesn't that make sense? Half are below 68 because 68 is the mean, just like I said in class. Half of my students are shorter than me, half are taller than me. So I don't need this calculator. Again, though, the calculator helps me color this and understand what each of these numbers mean. All right, question number 2. Using the information above, only about 5% of young men have height outside this range. So they're talking about this range, meaning I need a range of values. So A says 65.5 to 70.5. We could type that in. That was wrong. But we can look at it. That doesn't look like only about 5% of young men have those outside that range. And again, we can go here and type outside, but it seems obvious that one's wrong. Let's look at B. It says outside the range 63 to 73. All right, if I hit calculate, recalculate, notice it does say 5%. So outside 63 and outside 73 is left over. Now, if we look at this, we're like, oh, this is like our flip book. Notice that's 2 standard deviations to the left and 2 standard deviations to the right. So that's why it's called the 68, 95, 99.7 rule. So 68, 95, 99.7 rule, meaning 95 is between here, which means leftover on the outside, if I added these two together, would be 5%. Okay, don't really need the calculator, but again, the calculator illustrates that. Now for question 3, it says for the density curve on the right, so the density curve means just the word density means the area under the curve is between 0 and 1. So I would have taken that answer. It says the density curve is symmetrical. Symmetrical would mean if I fold it in half. So this is an example of symmetrical. I think I could make a weird shape that's symmetrical. You know, it could look like a plateau, but symmetrical meaning if I folded it, the left and the right would fold on top of itself. So it's definitely not symmetrical. Skewed right would look like that, and that's not what we have at all. This density curve is normal. No, this is what normal distribution looks like, bell-shaped and symmetrical. And so I also took none of the above because I think if you tried to do a little math and calculated the area under this curve, kind of approximating with a triangle, you may have noticed it was slightly off from 1. So I'm willing to accept A or E there. All right. For density curves shown above, which statement is true? So if we look at this, it also looks like many of our curves that are skewed left, correct? So if we think skewed left, that means the median would be somewhere here, and the mean would be pulled by these lower values, pulled to the left. So that's how we know the mean is less, because if it's left skewed, it's less. Many students put skewed right, so then they put the mean is greater than the median. It was actually the opposite of that. All right, let's look at the last one. It says, what's the area under a curve? So this is if you did it by hand here. You can also use the computer. So when is the area under the curve between -0.3 and 1.6 if we're just looking at z-score? So z-score means when we just leave the mean 0 and the standard deviation of 1, okay? That's when it's been standardized. So that's when we get to this website, that's the default. That's what it's already set on. That's when we turn any number into a standardized number. So if we move this back to 1 and 0 and 1, and we put what happens between, right? Between the values when z is -0.3 and +1.6. Recalculate, we get our answer, 56,301. And again, that looks like what we're describing. Z is -0.3 and +1.6. Notice our picture mimics what we're asking the graph to do, and the graph is finding the area under that curve. All right. Question number 6. A normal density curve has which of the following principles? So if we look at this picture, right, we're kind of describing this picture. Does a normal density curve, is it symmetrical? Yes. The left and the right are equal size. Is its peak centered above the mean? Yes. So this is where the mean is, and the peak is centered right above there. Is the spread of the curve proportional to the standard deviation? Yes. 1 standard deviation is proportional, 2 standard deviations, 3 standard deviations. So we are going to like the answer D. All right, now it says, how many professional schools require applicants to take a standardized test? Suppose that 1,000 students take the test, and you find that your mark of 63. So 63 is your score, right? And 73 is your percentile. Okay, percentile, right? So what does this mean? So this means that at least 73%, percentile means 73% of people scored, performed at or below your score. So at least 73% of people scored 63 or better. No, 63 or worse. So A can't be right because we fixed it, right? At least 270 people scored 73 or better. You didn't score 73. 63 is your score, right? So that's 63 or better. So that one can't be right. At least 730 scored 73 or better. Again, 73 is not your score. Your score was a 63, okay? At least 27% of people scored 73. No, your score is 63, right? At least 270 people scored 63 or better. Okay, so they kind of flip this on you. If 73%, so if we draw a picture, if your score is a 63, they're saying the area under the curve to the left is 0.73, which is the area under the curve to the right would be 0.27. So if, in fact, 1,000 people were surveyed, it would make sense that the last one, at least 270 people scored 63 or better. Okay, number 8, the yield of a variety of wheat was measured on a series of small plots. It was approximately normal. The 2nd and 98th percentiles were found. All right, second, and it meaning the area under the curve to the left was point. And if this is the 98th percentile, then that means this would also be 2% left, right? Because 100 minus 98 means there's 2% left that did better. So the second and 98th percentiles were found to be 29 bushel acres and 41 bushel acres. 29 and 41. So you know that the mean is exactly in between because they said it's normal, and you know it's symmetrical, so we can find out exactly in between there. Right, 12, and if we divide by 2, we get 6. Okay, so 6 plus 6 would be 35, right? Plus another 6 would be 41. So this is, again, kind of like our flip grid, just understanding how does normal work and how many standard deviations from the mean we're going here, right? So it says the standard deviation would be approximately what? Okay, again, a variety of ways we could do this. We don't know the standard deviation, but we could play around with it here. We know the mean is 35, and I'm going to start with just, if this is 68, 95, so this would be 94% of the data. So that's going to be close to 95%, right? Our empirical rule, 68, 95, 99.7 rule states that you would be able to capture 95% with 2 standard deviations. All right, so if 2 standard deviations makes 6, then it looks like it's got to be 3, okay? And that is the answer, but you could have guessed 2 and see what happens. So let's say I know the mean is 35, the standard deviation's 2, and what would be, again, you could say between 29 and 41. And you know that this area needs to be approximately 94%, and it's not. So that's why I did go too big on our standard deviation, too small, excuse me. So if I adjust the standard deviation to 3, yeah, that looks like from 29 to 41 bushels, the area under the curve is approximately 95. And so that's the closest one. If we go to 4 standard deviations, we notice it's not exact, but that 3 is definitely better. And again, the reason why it's not exact, see how that goes down to 86%? This doesn't look as close to what we were looking for. And the reason is we were supposed to be using this empirical rule to approximate it. We were not asked to find it exactly. We were asked to approximate it. So if we know this is 12 apart, and we cut that in half, we get 6 and 6, and we cut that in half again, we get 3 and 3. Okay, last one. If you know that this is the shape of something that's approximately normal, then the shape that's closest to that is this shape, okay? So if you're doing test corrections, you may want to just also list these other shapes. This would be skewed left, right? This would be what skewed right looks like. This could be what kind of uniform data looks like. So we have this in our activities where maybe this was rolling of dice and you know that it's going to happen 1/6 of the time, but you have some amount of variation. They're all kind of bouncing around this same value. That's it, guys. This video fixes 2A. Check out the next one to fix 2B.